Right, good afternoon, ladies and gentlemen. Welcome to another week of fun math. All right, so our objective for today is that students will be able to factor algebraic expressions. All right, now if you remember last week, we were working with the distributive property, and just remember that we said that the distributive property said if you have the product of A times B plus C, that's equal to AB plus AC. And again, just remember the distributive property is something that we use when we have variables. So if I had something like this, 4 times x plus 2, and I wanted to rewrite it, I don't know what x is, so the only way that I can proceed with doing something here is by distributing. So let's say 4x plus 4 times 2 is 8. So the distributive property tells us that these two expressions here are equivalent, right? Now, last week, what we actually did is we also, towards the end of the week, started reviewing the greatest common factor, right? And that's something that's going to come in useful today. So just remember the steps to finding the greatest common factor between two numbers is first to list out all the factors, figure out what factors they have in common, and then figure out what is the greatest of those between the two numbers, right? Now, using the greatest common factor together with what we know about the distributive property is going to help us start with expressions that look like this and factor them, work in the opposite direction to make them look like something like this, 4 times x plus 2, all right? And we're gonna go over a couple of examples just to explain all that, all right? Now, again, right, when we're factoring, the main thing is to try and make our expressions look like something that needs to be distributed. So let's say I'm starting out with the expression 6x plus 12, right? Obviously, this isn't something that needs to be distributive because there aren't any parentheses. But if I tell you that I want to factor that expression, remember, a factor is something that multiplies by something else. So I want to write it as a product of two different things. I want to write it so it looks like something that I would distribute, something like A times B plus C. That's the goal when I want to factor something, all right? So in order to get our heads around what factoring is, I'm going to show you two examples. So this example here, 3 times 2x plus 4 and 6 times x plus 2 are both examples of something that has been factored or something that I can distribute. So in this case here, just to show you, if I were to distribute this, I would say 3 times 2 is 6 with the x, plus 3 times 4 gets me to 12. Same thing over here. 6 multiplied by x is just 6x, plus 6 times 2 is just 12. So both of these expressions here give us 6x plus 12. That tells us that this, and this are all equivalent to each other, all right? Now, only caveat here is that when we talk about factoring expressions, usually we say that you want to factor it in its simplest form, which is going to involve the greatest common factor. So if I look at this example over here of 3 multiplied by 2x plus 4, that's not fully simplified because if you look at here between a 2 and a 4, they both have a factor of 2 in common. So I can kind of factor this out some more. So this here is actually kind of the most simplified that we could get, all right? So I'm just gonna show you another couple of examples of this, and then you're gonna try to practice this yourself, all right? But before we start, just to give you some steps on how to go about factoring an expression, all right? And these steps are things that you already know how to do. So if you know how to factor, you know how to find the greatest common factor, you can factor an expression, all right? Step 1, it says, is to find the GCF between the two numbers. So let's say I'm looking at the example over here. I have 5x plus 15. So the two numbers that I have are 5 and 15. First step would be to find the factors of 5. That's simple because 5 is prime. I only have 1 times 5. If I want to say factors of 15, I have 1 times 15. I have 2 doesn't work. 3 times 5. That's it. 4 is not a factor. 5 I already have here. So common factors are just 1 and 5. Now, the greatest common factor between those two is pretty simple. It's just 5. All right? So Step 3, it says write your factored expression as the product of the GCF. So the GCF between these two is 5. So first thing I'm going to put is I'm going to put a 5 here, multiplied by, right? It says divide both numbers by the GCF to determine the other factor. So what I mean there is 5 times what gets me to this 5 here. That's just 1. So it's 1x plus 5 times what gives me 15. That's 3. So 1x plus 3, but we actually really don't even need to put the 1 there. So we can just say, sorry, my eraser's not working. 5 times x plus 3 is how I would write this here in factored form. All right. Now, if I wanted to test that out, I would try distributing, right? I would say 5 times x gets me 5x, 5 times 3, 15. So this here is the factored form of this, and you can check your work by just trying to distribute it. Now, let's say I try the same thing over here. I have 4x minus 16. So let's start with what are the factors of 4, right? 4, I could say 1 times 4. I could say 2 times 2. 16 is going to have a few more. So I could say 1 times 16. I could say 2 times 8. Or I could say 4 times 4. Those are all my factors of 16. Now, just like before, I'm going to go ahead and first figure out what's the greatest common factor between the two, right? So my common factors actually have a lot here. I have 1, 2, and 4. Again, over here, 1, 2, and 4. So again, when you factor this, you want to use the greatest of the common factors, which in this case is 4. So to factor this, I'm going to say it's 4 multiplied by 4 times 1 gives me 4, so it's x here. In this case, I have a minus, so just bring the minus down instead of a plus. And then 4 times what gives me 16, so 4 here, right? 4 times x minus 4 is how I would write this in factored form. Again, if I check it out, 4 times x gives me 4x, 4 times 4 gets me to 16, so I check my answer. Now, with this example here, there's actually a couple of different ways that you can factor it, but this is the only one that's written with the greatest common factor of 4. Another way that I could do it is, let's say I used 2. I would say, okay, 2 multiplied by 2 times what gives me 4x. So I would have to say 2x, and then 2 times what gets me this 16, that's going to be 8. So 2x minus 8, this is another way that I could factor it, because 2 times 2x gives me 4x, 2 times 8 gives me 16. And again, I could even do that one more way. I could also do it, right, trying to use the 1. Can we do it with the 1? Let's see what happens. Let's say I did 1 multiplied by 1 times 4 x. This would get to be 1 times 16, 16. All right, so if I try to factor it with the 1, that doesn't really work because it just gives me what I started with, right? It's not really factoring if you only pull a 1 out. So both of these here are written in factored form. This one is the most simple because it's using the greatest common factor of 4, right? If this is a little confusing, just try rewatching it again. And then I want you to go ahead and try to practice what we have in part 2, all right? Sorry, part 1. So you're answering the 4 questions on this page plus the 4 questions on this page. Then once you're done, I want you to try to use this fact here to answer these push yourself questions here. All right, make sure you come to the Zoom session, and I'm going to try to help you out with this stuff here. It's going to come in handy next year when we get to algebra, all right? Good luck.